Hey folks, so this is a new video. I just decided last minute to do it because it is quite an interesting thing that I'm doing. This is my battery from the Engwe T14. I've got a few electric bikes, but this is one of them. I've also got a DYU A5, and I've just taken out the 4 screws at the top, 4 screws at the bottom, and then I paused to grab my camera. I'm installing a smart BMS, so I thought actually looks quite a nicely made battery, other than it's plastic and aluminium on the outside coast there. So let's kind of do it together. This is not going to be the most comprehensive video, but it will show you roughly what it's like inside the battery, and yeah, we can talk a little bit about it. So yeah, inside you have, this is for the main power going at XT60 plug, and a fuse on there, which I don't know how big it is, and the battery just slots in there. It sometimes feels, when you do this sort of thing, it's a bit of a shame because you have to take it all out. It's all packed in here, all nicely done, but I think it's worth it really, because I want to be able to rapid charge it, and that actually entails taking out the battery, taking it, opening it all up, and then I have to basically just put a better battery management chip in there so that it can take more amps when I charge it, because at the minute it's limited to, I think it's 3 amps, and it's a 48 volt battery. So at the minute, if it's quite dead, the charger seems to put out 115 watts or so, which means it's several hours to get it charged up, and I want to do it in less than an hour. So, like I do my normal bike, my other bike in Australia, like for a long ride. I normally take it for long rides, and then I have I want to charge it quickly, 600 watts rather than 115, 120. So that's what's happening. This battery was sat here just mostly full, 85%. I've just stuck it onto I actually just plugged it straight into this. This is my All Powers R1500. I've got a couple of these actually, and I've got a solar panel too there, but I haven't used it yet. A couple of companies sent it out to me. I've got a few YouTube channels actually, so this one is not very big. I don't get paid for it as it is now. So the label says, you can see here, that's the label, so it's meant to be 499 watt hour. It is. It actually is. It's surprisingly easy to get out. So actually on the top here, they've put 2 little blobs of silicone stuff there, adhesive, which kind of touched the side of the plastic, which sort of glued onto there. But actually, if you just stick a screwdriver in there and just break that off, just stick it in and go up and down a bit, that's loose. The whole battery has just got these bits of foam in there like that to stop it bouncing around, and then it's really easy. You just push it from the bottom in there, and it just comes straight out. It's really like one finger sort of out, and then you just go behind the green plastic, peel it off. So it was like that, you just peel it off, and then you just basically pull it off, kind of like the metal around a tin of soup, like that. It's a bit hard to do with one hand, but you just pull it off around the top, and then you have entry. Really, this is like a solid piece of thin plastic, and it's just all the way around. A couple of cast lines on the side there. Right, here we go. That's what I decided to do. In the end, I started cutting down there, but I'm going to just try and just only take the top off, which really is just a cap with a bit of tape around it. That's quite small. That's like a little basic, cheap, small one. I'm really quite glad I'm doing this, actually. And it's quite warm from when I discharged it at 600 watts, because when you plug this into here, this takes lots of different... There's an input thing on the side with a DC-DC converter, which means you can plug solar panels into it or batteries, and it will just take out up to a certain amount of amps. I think it's maybe 12 amps or something, 13 amps. And that was how I depleted this battery without having to ride the bike. Yeah, so it started coming out. Really a little bit tricky to get started, but actually you can just do it with 2 hands. You just pull the battery cells out of there, and then you end up with it just slides out, really. It's not happening with one hand, that's for sure. Oh no, maybe a little bit. There you go. But yeah, this is the quality of the work. It's pretty, it's a pretty basic job. It's not Xiaomi or anything like that. When you actually look at Xiaomi's products and Xiaomi scooters and things, they really do try quite hard to make them really well. This is pretty thin nickel strips, pretty basic, and that's okay. It's not too bad. I mean, it's an Engwe T14. It's not overly great, but it's all right. It's a nice little thing for the bike. But I've always been really impressed with Xiaomi stuff, honestly, from an electrical engineer standpoint. Xiaomi are some of the best things I've seen, really. If you look at genuine Xiaomi batteries, I think I have a video on my channel somewhere. You can have a look at that. But I'm not sure which one it is. I've probably got a couple. But they really do excel when they do their battery stuff and whatnot. But you know, that's alright. Look at that. Look at the quality. It's great. 48 volt BMS. It's a very basic one. It is very basic. 20 amps out, 3 amps in. And you know, it should do balancing. Does it do balancing though? Does it actually? It's supposed to. But this looks quite thin actually, so you just never know really. But it should do. So there it is. This is the battery. Just to cite what kind of battery cells are in there. There you go. 3.6 nominal INRs, 18650 26p, which suggests that it's a 26 as in 2600 milliamp hours. Oh, sorry, there we go, do it again. 4 in parallel, 13 series. I'm aware that this does not look professional at all, but I'm not a professional. I'm pretty good at doing it. I've done a lot. But I literally just arrived back in England 2 days ago to do this and to do some other things and to go on a couple of trips in Europe. And I have barely enough tools to do this, but I do have all the correct tools. And so I'm literally sat here with my music playing, you know, and I've got a bit of Saxon on the internet. There we go, a little bit of Saxon. Fantastic music. And I'm just replacing the BMS because I'm currently recovering from a lung infection. So this is pretty basic sit-down sort of stuff. And I honestly live for this, I really do. So anything like that, any questions, just put in the comments because actually other people will reply to you probably before I do. I don't always check the comments, but I will endeavour to because I know this sort of thing is tricky and there are usually lots of comments over the years with these sorts of videos. So this is what we've got inside. It's half decent. It's pretty neat. I like that they've used insulation tape and things like that with a sticky side up. Although it's probably a double-sided sticky tape. I like that they've done that. This is the new BMS that's going in. It's Bluetooth 7S to 14S, 30 amp. That's plus actually. 20 amps would have been fine, but 30 is a bit better. It's probably got better MOSFETs in it. And yeah, it's alright. Much better than that one for sure. It's like 30-40% larger. And this tape just comes off of these here. I really like that they've done this because this makes things way neater for me. So I'll take off all of these wires, take them all off, and then I'll just reattach everything. So every single wire on here, I will desolder the negative and the positive, which is down there, take it all off, and then I'll reattach them from the, later on when I've got this BMS in place here. I brought all my heat shrinks and everything, so we should be able to do a nice neat job of this. I will give you a quick explanation as to how this works. So the BMS will have, there are a couple of different types really, but basically this one is a one where you connect the negative directly from this. That negative there just goes straight to the negative on the battery. The positive on this only is not very long, so I'll have to extend that and run that down to here, basically. And then you've plugged in the positive, plugged in the negative. I'm not sure if there's a charge one as well, I'm not sure. Maybe there is, but sometimes there's a connection for the charging. Otherwise you just use the standard negative and positive that you see. You just connect that to the charging system as well. And all the balance cables here. So the way that these work is that you connect from the first positive, you go negative, positive 1, positive 2, positive 3, 4, 5, 6, 7, and then any that you've got left at the end on the very last one, you attach them all together, which on this BMS will only be 2 wires instead of more, which is, I'm fine with that. And yeah, that's how you do it. And then it knows automatically, and then you download the app for the Xiaosheng. That's how you do it. And then you can set the minimum cutoff, the maximum charge voltage, things like that. You can set it to active balance rather than just balancing only at the top. Therefore, you can have it always balanced. Or the other negative, which is a big thing, is that the Bluetooth ones always take, I don't know, 1 watt of power or something like that, which means over a course of a couple of months, you'll notice you've lost quite a bit of battery. and that's definitely something to be aware of. A couple of things to note. I've just noticed this is actually genuinely quite crap. So this is the temperature probe here, and that's a bit rubbish, honestly. All they've done is dangle it through the wires, just loop it over, because they were too lazy to even use any sort of silicon RTV sealant or anything like that, silicon to attach it anywhere near the battery cells. So that is obviously never going to stop it charging, apart from, you know, unless the air within the cells here, this area, is hot enough. But that's not the point. This is meant to be, you know, touching the battery cells, and it's just not doing it. That's terrible. That's actually quite rubbish. Okay, so here we go. I've cut the positive wire off there. That goes right through to there. I've done the negative as well on the other side, just here. And the BMS wires I've actually just I just cut them off on there. A couple of reasons. One, it means I can spend less time resoldering because I know exactly which wires go where without as much thought. But also, I'm in this room with no extractor fan. I'm in a room with a window open, and so if I can put as little as possible into the air, that would be ideal. So I don't want to desolder it and then resolder it. Also, the more times you do a heat cycle on this solder, the worse it becomes. And I do have some Weller solder. I definitely worth not getting anything from AliExpress with regards to solder, because it's generally rubbish. Maybe there are some that are decent, but usually my experiences are that they're all rubbish. And if you try cheaper stuff and things from AliExpress, and then you try some genuine Weller solder, it is fantastic. I'll never go back. It just works beautifully in a really hard to explain way. It just does, and it's not expensive. So definitely just spend a few extra dollars and get Weller solder, because the experience of soldering will be so much easier. So yeah, that's it. This is the BMS anyway. That's really the only label on it. It's a bit basic. There you go, if you can see that. That's it. It's just a bit basic, really. So here we go. I've basically stuck this back on. So the BMS, the new one, is now on the top there. I use a bit of tape, and it also just sticks on the top here, which is great. These balance cables, on the last one, they went on here like this. And so the idea is now to cut each one to a really lovely length with a little bit of spare in it, and then you just solder them on one at a time. Once you've done that, it should work lovely. But before you do that, take the plug out of the BMS and then plug that in finally at the end, and then we can go about finding the best spot for the temperature probe, and also start attaching the main power cables to this. But basically, the balance cables give power to the BMS, and then the Bluetooth will start to work. So that's what I normally do first. So let's start chopping through these wires, starting at the negative, and then you go negative, positive 1, positive 2, positive 3, positive 4, positive 5, 6, 7, 8, 9, 10. The last two go together, done. That's that. BMS will be plugged in and should be live. Okay, here's what we're going to do with the temperature thermometer. So I've put that around here, around the top there, around the back of this sponge, and I've stretched it across just quite a neat amount. And then I will slide it under there. That's what I'll do. It was a bit blurry, sorry. There we go, put it around the back of there, and then you can just see it poke out the bottom there, look. Just there. And I'll just put some RTV sealant on that, which is RTV sealant, if you don't know, is it's kind of a silicone adhesive, and you can use it directly on all electronic components, and it's pretty good. And then it dries very, very sticky, and it's kind of an adhesive, really. That's the point. So that's very commonly used. I always use that on my things, and then that way there's a direct connection between the end of the thermistor to the cell of the battery. So I opted to get the slightly older version of the app because I think it's actually better. You've got much more functionality. So it says currently now 24.1 degrees there if I touch the thermometer at the end. Here, if I just grab it with my fingers, like now, We should see that just start going up. There we go. Here we go. So I've put the positive cable back on. I've attached the negative from the BMS, which only had to go to there, so I've cut that short. And I've put a little bit of RTV sealant on the thermometer, so then it sort of goes around from here, tucks around the back neatly, sits in there. That will be glued, that will be good. Here we go. So that's it, that's the extra port. I appreciate that looks a bit weird, but hey, that's the best I can do, and it works perfectly fine. And this is not really an expensive bike, is it? So they right, I've plugged the charger in. Here we go. There's a green light. You can't see that. There you go, green light. And this is the battery on here, and it says right there, power. That's how much power is going in, and also the battery percentage and voltage, etc., etc. And yeah. So let's give it a go. This is the first time it's been done. So plug that in there. Just push it in. Ooh, yeah, I can hear it. It's working. And they get 10 amps because it's a 10 amp charger. And it's a 48 volt battery. So the wattage will go up as it gets more charged. There you go. Cool. It works. There you go. Definitely worth doing. I've had one of these before. And I bought another couple for my DYU A5 and the Engwe T14. So I'll give this a go, have a good couple of rides on it, and any issues or anything, I'll make another video. Please feel free to subscribe. This is a newish channel. I don't really post that much to it, but I'd like to keep posting some little hobby things like this on it. If you're interested in electric transport, battery building, e-bike projects, weird little things really, weird little things, I will do them, so feel free to subscribe. Right, so it's charging from 17% to, I'm going to go to 80%. So this is where it's at now. It's been on for, I don't know, 2 minutes or something, 1 or 2 minutes. Something like that, I don't know, we'll see. It's at its charge time, 48 minutes. Who knows? We'll know soon. And yeah, you can see, maybe you can see on the top there, 6:01 AM in the morning, and it has 20%. 6:01. We'll see how that goes. Obviously at the top, when it gets to, I don't know, 80 or 90, it will taper off a bit. Still going strong. 10 amps, and it's about, where is it? About 70%? There you go, 70%. 6:32, so it's been on 20-30 minutes. Here we go. It's now only just started to ramp down, so 53.8 volts. It's going to go to 54.6, something like that. And now just slowed down to 500 watts. And that has taken, there you go, 6:48. So it's pushed it right up to that in, I don't know, 48, 49 minutes.